Hi everyone, my name is Abdulrahman al-Yamani, a PhD student working under Wassim supervision at Cardiff University. In this presentation, I will briefly discuss our research into machine learning method for clustering architecture precedent, which is focused into classifying the relationship between building and ground. This presentation is structured as follows, starting with the introduction to the topic of classifying the relation between building and ground using unlabeled machine learning method and explain our aim and objectives. Then explain the research contribution of our work. Then we will explain the general framework and the proposal of the framework. Then we will discuss the experiment we set up and its result. So our aim of this research is to propose a novel proof of concept workflow that enables machine learning computer system to cluster aspect of architecture building design style with the respect to how the building in question is related to the ground. Example of this architecture precedent here it shows different approach of architecture style to the ground. Previous work has been limited to using an image database to classify and cluster architecture style. Although this approach are interesting, they don't allow the machine to cluster the data without supervision or tagging of image. To the best of my knowledge, no work has been carried out using unlabeled data unsupervised to cluster architecture style. The significance of this research is to help both academic and practitioner architects to understand and identify the topology and topological characteristic of their architecture figure and ground sentence and place and place it within the most relevant architecture canons. This in turn will supply a large amount of knowledge of the various building ground relationship. To test this idea, we implement a workflow that's connected with the three main pieces of software. Firstly, Microsoft Access. Secondly, Python program. And finally, scikit-learn library, which is a free machine learning software library for the Python program language, was used to implement k-mean and k-modes and GMM algorithm. The workflow begins with the collecting 139 residential precedents and sorting them into Microsoft Access. All the collected building data focus on three specific periods in history, which is modernism, postmodernism, and contemporary. In the stage 2, we provide the Python with the Excel file. We call this stage input data. Stage 3, after reading the Excel file data, now the time to translate the non-numerical data to numerical data to enable machine learning to read it. Using scikit-learn library to implement the k-mean and k-modes and Gaussian mixture model algorithm, this is our final stage. In this experiment, we use this new method to demonstrate the clustering result, and we use elbow method to determine the optimal number of clusters. The k-means algorithm was run with a different number of clusters. The acceptable number of clusters confirmed with this kind of problem was found in the 8th cluster, where the silhouette score reached to 0.78 silhouette score, which is around 89%. In parallel, the K-modes algorithm was run using the same number of clusters. The best silhouette score was found with the cluster 9 with a rating 0.76 silhouette score around 88%. While both clustering algorithms relieve strong accuracy, the K-mean method yield a better overall silhouette score with the less time. The GMM algorithm was run in different number of clusters also. The purpose of using the GMM was to locate uncertainty in the group. The testing of the GMM experiment shows that there was no overlap between the clusters, which is mean that all groups were certainly partitioned. Moreover, it still obtained a good accuracy result, such as 0.75 silhouette score, which is around 87.5%. To visualize the result, testing result was split into group of images. Cluster 0 presents a similar architecture style, which is involved interlock approach to the ground. Cluster 1 shows a similar approach to the ground, which is separation. Cluster 2, all example shows how the building sit to adherence the ground. Finally, in the cluster 3, all the examples shows the similar approach to the ground, which is interlock with the more anchoring to go under the ground. The limitation in this paper that we only focused in the residential architecture precedent. Also, there are many alternative approach to cluster that can be used, such as K-modules and fuzzy C-means. To conclude, this paper has suggested a new proof of concept workflow that enables machine learning automatically discover how different architecture design the architect design the relation between building and surrounding ground. Also, our finding demonstrate that K-means, K-modes, and GMM achieve a high accuracy on clustering architecture style. Future work will concentrate on using different data to generalize this approach. This slide shows a part of my PhD workflow. The part that highlighted in red was published on eCAADe2020 conference, and this paper is highlighted on gold. Thank you for your listening, and please don't hesitate to contact us if you have any comments or questions.